Please subscribe my channel and don't forget to press bell icon to get notification about all new videos. Thank you.
Bismillahirrahmanirrahim. Today our topic is to discuss the basic Boltzmann relation to calculate the plasma temperature. If we take the natural log on both sides of Boltzmann relation, we get natural log of 1 over hc lambda I divided by aki gk is equal to minus ek divided by kbt plus some constant, where lambda is wavelength, I is intensity, ak is transition probability, and gk is statistical weight. In this relation, h is the Planck's constant, which is equal to 6.63 into 10 power minus 34 joule second, and c is the speed of the light. hc is equal to 6.63 into 10 power minus 34 joule second into 3 into 10 power 8 meter per second. We get 1.98 into 10 power minus 25 joule meter. Now we have to calculate this in joule nanometer. In the unit of joule nanometer, hc is equal to 1.98 into 10 power 16 joule nanometer. Take inverse on the both side. 1 over hc is equal to 1 by this factor, which is equal to 5.02 into 10 power 15 joule nanometer inverse. And kb is Boltzmann constant. In the unit of joule per Kelvin, kb is equal to 1.380649 into 10 power minus 23, and Aj per Kelvin 1.380649 into 10 power 16. Another unit of energy is per centimeter, and in the unit of per centimeter, 1 by kb is equal to 1.438. Using these values of 1 over hc and 1 by kb in equation number 1. This is equation number 1. Natural log of 1 over hc lambda I divided by ak gk is equal to minus ek divided by kb t plus some constant. The constant has been ignored to calculate the plasma temperature. Relation become natural log of 5.02 into 10 power 15, which is the value of 1 over hc. Lambda I divided by ak gk is equal to minus ek divided by t into 1.438. This is the value of 1 over kb. By rearranging the above relation, we get natural log of 5.02 into 10 power 15 lambda I divided by ak gk whole divided by 1.438, which is equal to minus 1 over t into ek. This is equation of the straight line. Y is equal to mx plus c. The constant portion in the Boltzmann plot have been skipped. It is not required for plasma temperature. We use it to calculate the concentration of element present in the sample. By comparing above equation number 2 and equation number 3, this is the equation number 2 and this is the equation number 3, we get y is equal to natural log of 5.02 into 10 power 15 lambda I divided by ak gk, and x is equal to the ek, where m slope is 1 over t. We calculate plasma temperature from the slope. Temperature is equal to minus 1 over slope. Thank you.